ಅಲ್ವಾ ಅವರಪ್ಪ ಏನ್ ಕೆಲ್ಸ ಅವ್ನಿಗೆ ಅದುತ್ತಾರೆ ಕೊಟ್ಟೋದು ಬಿಟ್ಟೋದು
ಇಬ್ರಿ Good evening, students. So, electric potential and capacitors. I think before your exams, we discussed these questions. So, idರಲ್ಲಿ ಸ್ವಲ್ಪ questions pending ಇದೆ that we will continue. So, few we have completed from this slide. So, here is your next question. So, these all we have completed. Yes. Just 1 minute. Okay. So, I hope the PPT is visible to you. Yes. So next question on the electric potential and capacitor is the electric potential at a point xyz is given by V is equal to minus x square y minus xz cube plus 4. The electric field at the point is. Yes. So potential ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ minus x square y minus xz cube plus 4 ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. Electric field ಎಷ್ಟಿದೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. Okay, so electric field is equal to ಏನ್ ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ ಸ್ಟೂಡೆಂಟ್ಸ್? So electric field is equal to electric minus dou v by dou x ಅಂತ ಬರುತ್ತೆ. So here minus into bracket dou v by dou x with respect to I cap plus dou v by dou y j cap plus dou v by dou z into k cap. Right? This is equal to, so I cap inside dv by dx ಅಂದ್ರೆ with respect to x differentiate ಮಾಡಬೇಕು. I hope you know the differentiation formula ಗೊತ್ತಿದೆ ಅಂತ ಅನ್ಕೊಳ್ತೀನಿ. The differentiation of x to the power of n is given by n into x raised to n minus 1. Okay, so same you need to apply here. ಒಂದು ಮತ್ತೊಂದಂದ್ರೆ dx ಅಂದಾಗ ನೀವು ಬರೀ x ಟರ್ಮ್ಸ್ ಇದ್ದಲ್ಲಿ ಮಾತ್ರ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿ, y ಟರ್ಮ್ಸ್ ಇದ್ದದನ್ನ as it is ಇಡಿ. ದೆನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಸೆಲ್ ಇದೆ ಅದು 0 ಆಗುತ್ತೆ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್. ಐ ಹೋಪ್ ನಿಮ್ಗೆ ಇಷ್ಟು ಗೊತ್ತಿದೆ ಅಂತ ಅನ್ಕೊಳ್ತೀನಿ. ದ ಫಸ್ಟ್ ಒನ್ ಇಸ್ ಮೈನಸ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಇಂಟು ವೈ ಅಂತ ಇದೆ. ಸೊ ಮೈನಸ್ ಹೊರಗಡೆ ತಗೊಳ್ಳೋಣ. ಸೊ ಮೈನಸ್ ಹೊರಗಡೆ ತಗೊಂಡ್ರೆ ಹಿಯರ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಇಂಟು ವೈ ಏನಾಗುತ್ತೆ 2xy ಅಂತ ಆಗುತ್ತೆ ಪ್ಲಸ್ ಸೆಕೆಂಡ್ ಟರ್ಮ್ ಏನಿದೆ ಇಲ್ಲಿ ಎಕ್ಸ್ ಝೆಡ್ ಕ್ಯೂಬ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ದಿಸ್ ಇಸ್ ಎಕ್ಸ್ ಝೆಡ್ ಕ್ಯೂಬ್. ಸೊ ಹಿಯರ್ ಪ್ಲಸ್ ಇಟ್ ಇಸ್ ವಾಟ್ ಎಕ್ಸ್ ಝೆಡ್ ಕ್ಯೂಬ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ವಾಟ್ ಝೆಡ್ ಕ್ಯೂಬ್. ಸೊ ದಿಸ್ ಇಸ್ ಫಾರ್ ಐ ಕ್ಯಾಪ್ ಪ್ಲಸ್ ಫಾರ್ ಜೆ ಕ್ಯಾಪ್ ಇಟ್ ಇಸ್ ಜೆ ಕ್ಯಾಪ್ ಅಂದ್ರೆ ಝೆಡ್ ಟರ್ಮ್ ಎಲ್ಲಿದೆ, ಸಾರಿ ಝೆಡ್ ಅಲ್ಲ ವೈ ಟರ್ಮ್ ಅಂದ್ರೆ ಫಸ್ಟ್ ಟರ್ಮ್ ಅಂದ್ರೆ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಬರುತ್ತೆ. ಸೊ ಇಟ್ ಇಸ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಕೆ ಕ್ಯಾಪ್ ಇಂಟು ಝೆಡ್ ಟರ್ಮ್ ಎಲ್ಲಿದೆ ನೋಡಿ ಈಗ ಸೆಕೆಂಡ್ ಅಲ್ಲಿ ಇದೆ. ಸೊ ಅದ್ರದ್ದು ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಏನ್ ಬರುತ್ತೆ 3x(z²) 3x(z²) correct. So this is your answer. E is equal to I cap 2x y plus z cube plus I x square into j cap plus k cap into 3z z² into x. Option D is the correct answer. Yes, is it clear? So ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಕೇಳಿ. ಯಾರಿಗೆ ಅರ್ಥ ಆಗಿದೆ ಯು ಕ್ಯಾನ್ ಗೋ ಫಾರ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್. Next question is, charge Q2 is at the center of a circular path with radius r. Work done in carrying charge Q1 once around this potential path would be. Yes, you need to calculate the work done in carrying charge Q1 around the equipotential path would be. ಸೊ ನಿಮ್ಗೆ ನೆನಪಿದ್ರೆ ಇಕ್ವಿಪೊಟೆನ್ಷಿಯಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಅಲ್ಲಿ ನಾವು ಸ್ಟಡಿ ಮಾಡ್ಬೇಕಾದ್ರೆ ಇಕ್ವಿಪೊಟೆನ್ಷಿಯಲ್ ಸರ್ಫೇಸ್ ದ ವರ್ಕ್ ಡನ್ ಆನ್ ದ ಇಕ್ವಿಪೊಟೆನ್ಷಿಯಲ್ ಸರ್ಫೇಸ್ ವಿ ಡಿಸ್ಕಸ್ ಇಟ್ ಆಸ್ 0. ಇಸ್ ಇಟ್ ರೈಟ್? ಸೊ ಕೊಟ್ಟಿರೋ ಸರ್ಫೇಸ್ ಇಕ್ವಿಪೊಟೆನ್ಷಿಯಲ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. therefore the work done will be 0. Option C is the correct answer. Yes, both the questions are clear. Yes, Meghna, Archana, correct. Okay, other students, if you have copied down, we will go for the next question. Okay, the next question. Let's see the next question. 3 charges, each plus q, are placed at the corners of an isosceles triangle ABC of sides BC and AC 2A. D and E are the midpoints of BC and CA. The work done in taking the charge Q from D and D is. So D ಮತ್ತೆ E point ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. You just need to do some constructions, then you need to simplify this question. ಸೊ ಕೊಟ್ಟಿರೋ ಫಿಗರ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡೋಣ, ಸ್ವಲ್ಪ ಇಲ್ಲಿ ಚೇಂಜಸ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಏನಂತಂದ್ರೆ ದಟ್ ಇಸ್ ಹಿಯರ್ ಫಸ್ಟ್ ಪಾರ್ಟ್ ನೋಡಿ ಕ್ವಶನ್ ಅಲ್ಲಿ. So this is E and this is D, this much they have given. Okay, so here 3 charges plus Q are placed at the corners. So ಇಲ್ಲಿ plus Q ಇದೆ, ಇಲ್ಲೂ plus Q ಇದೆ, ಇಲ್ಲೂ plus Q ಇದೆ. Placed at the corners of an isosceles triangle ABC of side BC and AC, it is 2A. ಅಂದ್ರೆ BC ಮತ್ತೆ AC ಮಧ್ಯದಲ್ಲಿ ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, 2A ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. ಓಕೆ, D and E. ಸೊ ಇಲ್ಲಿ D ಮತ್ತೆ E ಏನ್ ಕೊಡ್ತಾ ಇದ್ದಾರೆ, ದಿಸ್ ಇಸ್ ದಿ ಮಿಡ್ ಪಾಯಿಂಟ್ ಆಫ್ BC and CA. ಕರೆಕ್ಟ್. The work done in taking a charge from D to Q ಎಷ್ಟಿರುತ್ತೆ, D to E ಎಷ್ಟಿರುತ್ತೆ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ಸೊ ನಾವೀಗ ಇಲ್ಲಿ ಏನ್ ಮಾಡೋಣ, ಇಲ್ಲೊಂದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಲೈನ್ ತಗೊಳ್ಳೋಣ ಫ್ರಮ್ A to D, then from B to E. Okay, so this is the external construction which we have done. Next simplification what we can do here, that is we need to calculate the potential at VD and the potential at VE. So ಅದು ಎರಡು ಆನ್ಸರ್ ಬಂದ್ಮೇಲೆ ನಾವಿಲ್ಲಿ ಕಂಪೇರ್ ಮಾಡಬಹುದಾಗಿದೆ. ನಮಗೆ ಪೊಟೆನ್ಶಿಯಲ್ ಗೊತ್ತಿರ್ಬೇಕಾದ್ರೆ ಮೊದಲು ಇಲ್ಲಿ ಡಿಸ್ಟೆನ್ಸ್ ಗೊತ್ತಿಲ್ಲ ನಮ್ಗೆ, AD ಇದ್ದು ಮತ್ತೆ BE ಏನೇನ್ ಡಿಸ್ಟೆನ್ಸ್ ಇದೆ ಅಂತ ಗೊತ್ತಿಲ್ಲ. ಸೊ ಹೌ ಟು ಟೇಕ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ದಟ್, ಪೈಥಾಗೋರಸ್ ಥಿಯರಮ್ ಅಪ್ಲೈ ಮಾಡ್ಕೋಬಹುದಾಗಿದೆ. ದಟ್ ಇಸ್ ಹಿಯರ್ ಆಸ್ AE is equal to CE is equal to A. Similarly, BD is equal to DC is also is equal to A. From the right angle triangle ADC, we have AD whole square is equal to AC whole square minus BC whole square. Correct. So you can substitute all the values here. AD we require, so AC, so AC from the figure it is 2A whole square, this is 2A whole square minus DC it is just A square, so it is 4A square minus A square, it is 3A square. So 3A square ಏನಾಗುತ್ತೆ, AD square ಆಗುತ್ತೆ. ನಮಗೆ ಬರೀ AD ಬೇಕಾಗಿದೆ ಅಂದ್ರೆ √3 into A ಅಂತ ಆಯ್ತು. ಕರೆಕ್ಟಾ? ಸೊ AD value is √3 into A. Now the VD value we can calculate. So potential is given by 1/4 pi epsilon naught inside the bracket. So ಮೂರ್ ಕಡೆ ಚಾರ್ಜಸ್ ಇರೋದ್ರಿಂದ ಸೂಪರ್ ಪೊಸಿಷನ್ ಪ್ರಿನ್ಸಿಪಲ್ ತಗೊಳ್ಬೇಕಾಗುತ್ತೆ. Q by BD plus Q by DC plus Q by AD. Bracket complete. We can substitute the values, take the Q outside, Q inside the bracket. We are left with, it is 1 by A plus 1 by A plus 1 divided by √3 into A. Okay. So just simplify and write what you are going to get. So ಇಲ್ಲಿ ಏನ್ ಬರುತ್ತೆ ನೋಡಿ, this is equal to Q divided by 4 pi epsilon naught. Next ಇಲ್ಲಿ ಏನಿದೆ ನೋಡಿ, 1 by A plus 1 by A, that is nothing but 2 by A. ಮತ್ತೆ ಇಲ್ಲಿ A ಕೂಡ ನಾವು ಕಾಮನ್ ಆಗಿ ಹೊರಗೆ ತೆಗಿಬೋದಾ? So remaining is what, 1 plus 1 plus 1 divided by 3. So that is nothing but what, Q divided by 4 pi epsilon naught into A, it will be 2 plus 1 divided by √3. 2 plus 1 divided by √3. Correct? ಇದು ಬರೀ VD ಆಯ್ತು. So same way can you calculate VE? Meghna, option A. Option A, no. Once again you check. Yes, correct. Yes, Archana, correct it is. Yes, students, VD ಮಾಡಿದ್ವಿ, ಅದೇ ರೀತಿ VE ಮಾಡ್ಬೋದಾ? So VE ಕೂಡ ಸೇಮ್ ಬರುತ್ತೆ. VE is equal to, okay, students are getting the answer, very good. It is 1/4 pi epsilon naught. Q ಇಲ್ಲೂ ಕೂಡ ಕಾಮನ್ ಬರುತ್ತೆ, ಹೊರಗಡೆ ತಗೊಳ್ಳೋಣ. Inside the bracket ನಮಗೆ ಮತ್ತೆ ಇಲ್ಲಿ 1/a plus 1/a plus 1/a into root 3 ಅಂತ ಉಳಿಯುತ್ತೆ. So therefore, if you simplify this, it will be Q divided by 4 pi epsilon naught into a. Inside the bracket 2 plus 1 by root 3. Correct? So ನಮ್ಗೆ ಏನ್ ಕೇಳಿದ್ರು ಅವರು? The work done. So work done is equal to VD minus VE ಅಂತ ಆಗತ್ತೆ. So what is VD minus VE? As both the values are same, the work done will be 0. So Shreya, D, D correct. C, no, D it is correct, Shreya. Reshma, yes. Others? If you have any doubt in the question, you can ask. Okay. So let us go for the next question. Moving towards the next question. Yes, in bringing an electron towards another electron, the electrostatic potential energy of the system. In bringing an electron towards another electron, the electrostatic potential energy of the system becomes 0, increases, decreases, remains same. Yes, what you feel? Yaud barbodu? Yes, your answer. Yes, Aishwarya, Archana, Kavyashri, Kirti, Meghna, Shreya, Nandita, Rashmi, Anjana, Spurti, Sanjay, Vinushri. Oh my God. Yes. Yes, your name is showing only red. It's correct. It is correct answer. What about others? So it increases. Correct answer is it increases. Ill nodi. Here what happens when you are bringing an electron towards another electron? The force of repulsion irutte hauda. So force of repulsion irodrinda work has to be done. So work extra madbekagutte illi because of the force of repulsion. The work done stored as electrostatic potential energy. So work done is more, the electrostatic potential energy is also more. Yes, yes, very good. Okay, then the next question. Okay, an electric dipole of dipole moment P is aligned parallel to a uniform electric field E. The energy required to rotate the dipole by 90 degrees is. So you need to calculate the energy required to rotate the dipole by 90 degrees. That is the potential energy is equal to minus PE into bracket cos theta 2 minus cos theta 1 for the dipole. Angle ಇಲ್ಲಿ ಏನೇನ್ change ಆಗ್ತಾ ಇದೆ? Theta 1 is equal to 0 degree to theta 2 is equal to 90 degree. Therefore, U is equal to minus PE into bracket cos of 90 minus cos of 0 is it is equal to minus PE. So cos 90 is 0 minus cos 0 is 1, which is equal to minus into minus plus. Therefore, it is plus PE. Option B. Who else got the answer? Yes, Meghna, correct it is. Option B is right. Other students copying, writing, what you are doing? Reply. Okay. Then the next question. An electric dipole of moment P is placed in an electric field of intensity E. The dipole acquires a position such that the axis of the dipole makes an angle theta with the direction of the field. Assuming that the potential energy of the dipole to be 0, when theta is equal to 90 degree, the torque and the potential energy of the dipole respectively. So just new formula ಬರಿಬೇಕಾಗಿದೆ ಅಷ್ಟೇ. There the question answer is not there. Just ನೀವು ಫಾರ್ಮುಲಾಸ್ ಹೇಳ್ಬೇಕಷ್ಟೇ ಮತ್ತೇನಿಲ್ಲ. ಟಾರ್ಕ್ ಮತ್ತೆ ಏನ್ ಕೇಳ್ತಾ ಇದ್ದಾರೆ, ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ಸೊ ನಿಮ್ಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ, ಫಾರ್ ದ ಡೈಪೋಲ್ ದ ಪೊಟೆನ್ಶಿಯಲ್ ಇಸ್ ಗಿವನ್ ಬೈ PE sin theta. So the torque is given by for the dipole. Then the potential energy for the dipole is given by ಈಗಷ್ಟೇ ನೋಡಿದ್ವಿ minus PE cos theta. Just you need to choose that option. So ಈಗ ಕೊಟ್ಟಿರೋ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ A ಆಪ್ಷನ್ ಆಗಿತ್ತು. So torque is equal to potential energy is equal to. Yes, go for the next question. The next question is, an electric dipole of moment P is lying along a uniform electric field E. The work done in rotating the dipole by 90 degree is. How to solve this? Work done is equal to the 0 to theta PE sin theta into d theta, which is equal to 0 to theta, that is 0 to 90 degree. So we'll just change it. It is PE sin theta can be written as 1 minus cos theta into d theta. Okay, so here the theta value is 90 degree. Therefore, the W is equal to this PE into bracket 1 minus cos 90. So cos 90 is 0. So 1 minus 0. Therefore, work done is equal to ಎಷ್ಟು ಬರುತ್ತೆ? PE ಅಂತ ಬರುತ್ತೆ. That is option A. Yes, anybody got the answer? Go for the next question. Yes, what about the next question? An electric dipole has the magnitude of its charge as Q and its dipole moment is P. It is placed in a uniform electric field E. If its dipole moment is along the direction of the field, the force on it and its potential energy are respectively. Yes, how to do this one? Here the total force on the dipole is 0. Why? Because it is Q is equal to F is equal to Q into E, and this is applied opposite direction. Therefore, the F value will be 0. Okay, so first answer you got. Next, the potential energy is given by what? Minus P into E, which is minimum. The minus P into E, it is minimum when this P and E are parallel. ಯಾವಾಗ ಇದೆರಡು parallel ಇರುತ್ತೆ, PE will be minimum. Therefore, option A is the correct answer. Proceed. C is the correct answer. Yes. Who gave Reshma? Yes, correct it is. Okay. So let us go for the next question. See, there is an electric field E in X direction. If the work done on moving a charge of 0.2 coulomb through a distance of 2 meter along a line making an angle 60 degree with x-axis is 4 joule, then what is the value of E? Yes. So the charge is given as 0.2 coulomb at the distance 2 meter and the 60 degree ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. Work done is 4 joule. ನಮ್ಗೇನ್ calculate ಮಾಡ್ಬೇಕಾಗಿದೆ? Then what is the value of electric field? ಹೌದಾ? So here we can equate two equation. One is work done is given by FD cos theta. ಹೌದಾ? So 9th standard ಅಲ್ಲಿ ಕಲ್ತಿದ್ರಿ. Work done is also given by force into displacement. So dot product ಇರೋದ್ರಿಂದ FD cos theta ಬರುತ್ತೆ. This is also is equal to the work done QED cos theta. How? That is work done is equal to potential is equal to work done per unit charge. So here work done is given by potential per unit charge. Therefore, potential is equal to W into Q. So we require work done. Therefore, it is sorry, one second. This is is to work done by charge. Yes. So now potential is equal to work done divided by charge. Therefore, work done is equal to V into Q. So V value potential ಕೊಟ್ಟಿಲ್ಲ question ಅಲ್ಲಿ. Therefore, convert it in terms of electric field intensity. ಅವಾಗ ಏನಾಗುತ್ತೆ ED into Q ಆಗುತ್ತೆ. Potential ಮತ್ತೆ field relation. Okay. This is equal to W. So that only we are substituting. So cos theta on both the side it will get cancel. D value will also get cancelled. We require the electric field value. Therefore, the electric field value is equal to force is given. No, force is also not given. So therefore, what we can do here, we can write two equations separately and equate the terms. That is better. So here work done is equal to FD cos theta, which is also is equal to QE into D cos theta. ಆಯ್ತಾ ನಾನೀಗ ಏನ್ ಮಾಡ್ತೀನಿ this and this. So therefore E is equal to W divided by Q into D into cos theta. So W is how much? It is 4 divided by Q is how much? It is 0.2 into D is how much? It is 2 into cos of 60. Yes, so this is better way to simplify. So if you simplify this, how much you are getting? Check. Anyone can answer this? Yes, students, what is the answer? Yes, ಬರ್ತಾ ಇದೆ. Aishwarya B 20. Yes, correct it is. Others, again, who else got the answer? Yes. Okay, students, very good. Go for the next question. An electric dipole moment P. Yes, Archana. Next question, please. An electric dipole moment P is placed in the position of stable equilibrium in uniform electric field of intensity E. This is rotated through an angle theta from the initial position. The potential energy of the electric dipole in the final position is options minus PE cos theta, PE 1 minus cos theta, PE cos theta, option D, PE sin theta. Option A or option B. See here, to orient the dipole at an angle theta from its initial position, work has to be done on the dipole from 0 is equal to, sorry, theta is equal to 0 degree to theta. Therefore, the potential energy can be given as PE into bracket 1 minus into bracket 1 minus cos theta. That is option B is the correct option. Yes, yes, totally correct. Okay, students, for the next question now. some charge is being given to a conductor, then its potential is maximum at the surface, maximum at the center, remains same throughout the conductor, maximum somewhere between the surface and the center. Yes. So same charge is given to the center, the conductor andre ಏನಾಗುತ್ತೆ, the potential is a. So when you are giving charge to the conductor, it will be uniformly distributed. Then its potential is, so the remains same throughout the conductor. Option C is the correct answer. Option C. Okay. Because the charges will reside only on the surface of the conductor. Therefore, here it remains same throughout the conductor. Okay. So option C. Then the next question. Yes. So here both the questions almost the same solutions it is there. So one I'll explain you, one you try. So two metallic spheres of radii 1 centimeter and 3 centimeter are given charges of -1 into 10 raised to -2 coulomb and 5 into 10 raised to -2 coulomb respectively. If these are connected by a conducting wire, the final charge on the bigger sphere is. The final charge on the bigger sphere we have to calculate here. That is Q value we require. So this is V is equal to Q1 plus Q2 divided by C1 plus C2. Okay. So first common potential calculate ಮಾಡ್ಕೊಳ್ಳಿ, ಆಮೇಲೆ ನಿಮಗೆ ಚಾರ್ಜ್ ತೆಗಿಲಿಕ್ಕೆ ಬರುತ್ತೆ. Otherwise you cannot do this. So Q1 Q2 they have given in the question. ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ? That is -1 into 10 raised to -2 plus 5 into 10 raised to -2 divided by C1 capacitance for the sphere. It is given by the formula. For the sphere it is 4 pi epsilon naught into r. So il radius r1 ಇರೋದ್ರಿಂದ ನಾನು ಇಲ್ಲಿ r1 ತಗೊಳ್ತೀನಿ. And here it is epsilon naught to r2. Yes. So this is equal to. So numerator ali 5 plus minus 1. It is 4. It is 4 into 10 raised to -2. This whole divided by 4 pi epsilon naught. I can take out common. Then r1 plus r2 ಇರುತ್ತೆ. Therefore r1 plus r2. R1 is 1 centimeter and 1 into 10 raised to -2 plus R2 is 3 centimeter. It is 3 into 10 raised to -2. So if you simplify this, you are left with only 1 upon 4 pi epsilon naught. Aita? So this is V value. If V value is there, go for the final charge on the bigger sphere. The final charge on the bigger sphere, it is given by C2 into V. So C2 is 4 pi epsilon naught R2. R2 value you can take it as 3 into 10 raised to -2 into V value 1 upon 4 pi epsilon naught. Yes, this is equal to your charge Q. So 4 pi epsilon naught cancel ಆಗುತ್ತೆ. ನಿಮಗೆ ಬರೆಯುವುದೆಷ್ಟು 3 into 10 raised to -2. Yes, who have not understood, you can ask. Option B ಬರುತ್ತೆ ರೇಷ್ಮಾ, not C. Check where you went wrong. Option B. So ಎಲ್ಲಿ wrong ಇದೆ check ಮಾಡಿ. Yes, students, same go with the second one. ಸೊ ಸೆಕೆಂಡ್ ಒನ್ ಅಲ್ಲಿ ವ್ಯಾಲ್ಯೂಸ್ ಎಷ್ಟೆಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ. ಚಾರ್ಜಸ್ 10⁻², 10⁻², ಮತ್ತೆ 1 ಮತ್ತೆ 2 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಅಂಡ್ ದೆನ್ ನೆಕ್ಸ್ಟ್ ಆನ್ ದ ಸ್ಮಾಲರ್ ಸ್ಪಿಯರ್ ಅಂದ್ರೆ 1 ಸೆಂಟಿಮೀಟರ್ದು ಏನ್ ಸ್ಪಿಯರ್ ಇದೆ ಅದ್ರ ಮೇಲೆ ಚಾರ್ಜ್ ಎಷ್ಟು ಅಂತ ಮಾಡ್ಬೇಕಾಗುತ್ತೆ. ಸೇಮ್ ಸ್ಟೆಪ್ಸ್, ಓನ್ಲಿ ಚೇಂಜ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಕ್ವಶನ್. Solve and tell me the answer now only. Do it fast. Same procedure. Who have not understood this one, you can ask me. Let's go for the next question simplification. D for 37. Yes, Spurti, Sanjay, yes, correct. Hope so other students you are also trying. D, yes. Okay, let us go for the next question. Yes, D is right. Let's go for this question. The last question for today's class. Solve it. Next class onwards, we will start with the current electricity. Yes. The capacitance of a parallel plate capacitor with air as medium is 6 microfarad. With the introduction of a dielectric medium, the capacitance becomes 30 microfarad. The permittivity of the medium is. Yes, you can also try this one. The permittivity of the medium is. Here C value it is given. C is equal to 6 microfarad. Then similarly, one more C is given, that is 30 microfarad in presence of the dielectric. So first dielectric constant ತಗೊಳ್ಳೋಣ. Dielectric constant is equal to ಎಷ್ಟು ಬರುತ್ತೆ ಹೇಳಿ? That is C dash by C. C dash is in presence of the dielectric. What is the capacitance? Divided by in absence. Okay, so microfarad ಇರೋದ್ರಿಂದ ಎರಡು numerator denominator cancel ಆಗುತ್ತೆ units. 30 by 6. It will be 5. So K5 bantiga. Permittivity of the medium ಕೇಳಿದ್ದಾರೆ. Okay, the permittivity relation we know, that is if you take epsilon is equal to K into epsilon naught. So dielectric constant is 5. ನಮ್ದು air ಇದ್ದು epsilon value ಗೊತ್ತಿದೆ. What is that? 8.85 into 10⁻². It is 8.85 into 10⁻². Okay, if you simplify, you will get the value of epsilon, and option C is correct. Who got the answer? Let me see. D, Shreya, check it once again. You should get option C. Yes, students, complete this. Next class, we will see. If on capacitance again, if I have the questions, we will do. Otherwise, we will go for the current electricity. Okay. Yes. Any doubt in the today's class, you can ask. Otherwise, in the next class, we will continue.